Welcome, I'm Wes, the sewing machine repair guy. We're in for some fun today. We're going to give this mini sewing machine the full sewing machine repair guy treatment. We're going to do the most in-depth sewing machine review on the internet of this mini sewing machine. Let's get started. And now it's time for the teardown of this mini sewing machine from random manufacturer not based in the United States. I don't think there's going to be much to see here, but you never know. We could be pleasantly surprised. So I already think you know from the last video, I'm not a big fan of the spring popping out at you whenever you try to change your thread. But that is something that will happen on this sewing machine. So the alignment of the presser foot on this thing is not correct. When the needle was going down, the presser foot, it was actually rubbing up against the presser foot. That's what I was saying before that I didn't like about it, that I really wanted to fix. And apparently you just bend it to fix it. So that's, you know, those kind of adjustments are easy but not permanent. And then again, we have a battery case that holds 4 AA batteries. The next thing I want to get out is my presser foot. Oh, that's screwed on there good. There we go. Boy, that... Oh, it's held on by a spring too. Okay, so if you look right here, you're going to see that there's a screw holding on the presser foot, and then there's a spring. Another, I like to call this sabotage, when someone sets something up so that it blows up as soon as you try to do something with it. So that's a joke. Okay. You might get a joke every once in a while from me. Don't expect it to last. I am a very dry, boring person usually. Okay, so now the spring, oh hey, that just, yep, there we go, got the spring out. So the spring's a little flared at the top. I don't know if you can see that. And there's really no reason for it to be, but you know, it is. Needle plate does not appear to come off until you tear apart the entire machine, which looks to be 1, 2, 3, 4, 5, 6 Phillips head screws. What am I expecting to see inside? Well, there's... I'm trying to think of how they control the motor, whether there's a resistor for the speed, whether it puts a resistor in series with the motor to get that lower speed, because it's going to be a DC motor, and you have a switch for high and low speed. So somehow they're changing the voltage going to that motor, and there's a potential that they have a resistor in there to limit that current for the motor. Okay, why is it one screw didn't want to come out? It's loose, it just didn't, oh there it goes. Alright. Okay, now the question is this thing gonna, our piece is gonna fly everywhere when I start to pull this apart? Okay, I'm seeing some gears. I just want to make sure that they will not explode. Do you think that, oh, see, right there. Yep. Okay. Alright. Looks like the top is a piece you're supposed to pull off. Okay. There's your needle plate. So the needle plate is not designed to be taken off without pulling the entire machine apart. That was a lot of negatives. You have to pull the entire machine apart to get the needle plate off. There, we made that a positive. So there we go. Okay, so these days these are all plastic, but this is the first one I've seen that has no means of providing any tension whatsoever. So this machine does not use tension, and I believe what they're doing is there's a magnet down in there. See that magnet? I believe what they're doing is that magnet is providing some resistance, because there's more resistance because of that magnet with me pulling this right now than there is if it was sitting by itself and me pulling it. So it actually provides some resistance, and that, I believe, is how they're getting their tension. Isn't that novel? Notice here on the bottom, so the two outside are where you're going to pull your voltage off to get that 6 volts. And so you got a blue wire coming off of here and a red wire coming off of here. These wires come around, so they're going to go through the switch. So here's your input power, right? Alright, the way this is wired, it's dangerous. If you were to put batteries in here that are non-rechargeable batteries and plugged it in, you would have a little thing that could go boom in your hands. I'm not going to use the B word, but this is not safe if you have batteries in here and then go to plug it in. So don't do that. So the first thing I'm talking about here is our electrical. I've already talked about the battery warning. Then as you come up, so you've got your switch right here. So that's your foot pedal. It's only an on-off switch. It does not do anything to control speed. So it allows the power to go to the motor. Then you follow your lines up. You've got your on-off. So this is in parallel with your foot switch. So either one of these will cause your motor to start running. Then you have your speed switch, and the way that they have done this is you want a lower voltage. So they put a diode in here. And what a diode does is it only allows current to flow in one direction. But in this case, they haven't used it for that because this is a DC circuit and current is only flowing in one direction. They've used that diode to drop voltage because a diode has an internal resistance, drops voltage by usually about 3 volts. So in this case, half the voltage is going to your motor when you're on slow speed, and then it takes the diode out of the circuit and you get your full 6 volt voltage on that motor to operate this. And we saw in the last video what our actual speeds were, and I'll put those right here, right now. Okay. Okay, that's enough electricity. Well, I mean, we do have a light, so the light's right here. The light also gets powered off of this stuff. Looks like, yeah, the light always has power. We saw that. The light was on every time this is plugged in, so no big deal there. The switches have a nice positive engagement. It's not bad. Alright, let's talk about the mechanicals here. We're going to start, let's start at the needle and work our way back. So from the needle, you know, this is all stamped out metal that's been bent to make your needle part. It has a hole for the thread to go through here to the front of the needle, and then it also holds the needle in place, a little bracket. It gets the job done. I didn't see any problems with that. Start to see problems when you get up here to a plastic piece that connects the motor to your oscillating shaft there. And since all this is plastic, and right here you have a very tiny plastic piece where this metal is rubbing right here. That right there is going to be your failure point. So at some point that's going to break because that's your smallest little piece of plastic that's holding metal. So if you use this a lot, which nobody ever will, but if you use it a lot, that piece right there would rub so much that eventually these two would be separated and your needle would no longer go up and down. Okay, so plastic to plastic, not a big fan. That's that part of it, and then we follow our torque. I'm calling it torque, so that's from the motor to the pieces that move. So you have a metal shaft here, which is good. It's probably the cheapest metal that they can find. It's not very precision, but it's good enough for this machine. And then comes back here to this plastic gear, to another plastic gear. This plastic gear goes to another metal shaft right here, going to this big plastic gear, which goes to a plastic gear on the motor, and then you have your motor. So the motor is actually mounted in there with plastic. There is no sound dampening, so that motor is going to be nice and loud, which it was. We kind of heard that, as well as all these gears are not meant to be quiet gears. So every single one of these gears, so you've got one mesh right there, a mesh there, so 1, 2, 3, 4, 5 places where these gears mess with other gears. Okay, so we said plastic gear, a whole bunch of plastic gears transferring all that torque from the motor to the needle and from the motor down to your hook. Your hook itself is plastic and it's pretty sharp. So sharp, if you know anything about plastic, when you have a sharp piece of plastic, it's not going to last. All right, so feeding. So you're feeding right here. Your feed dogs move up and down. Let's see if I can show this. You notice your feed dogs now, they're coming up. Move forward, they're coming down, back, move up, go forward. That's how it feeds your fabric. And all that is you have a cam on this plastic gear right here that moves this middle piece. Again, plastic on metal, that metal's going to win over time, and that's going to wear out the plastic. You know, when you put hundreds of thousands of stitches through here, because that's what you do with a child's sewing machine. We already noticed that there is no mechanism to loosen your tension. There's nothing on the back of this to loosen your tension at all, ever. This right here. Oh, okay. This right here. Normally when you do that, there's some lever in there that will loosen your tension, but this does not have that. So you're going to be pulling really hard every time you stop sewing, and even when you pull that, it likes to pull this lever down. It likes to pull this lever down, which puts more stress on the weakest point on the sewing machine. Alright, it's time to do some data runs of our mini sewing machine. We're going to see how this thing does with our different types of fabric. So let's see how it goes. 2 layers of fabric. Here's the electrical testing portion of the video. I'm going to make this quick. There wasn't much of a current change over the course of the testing. And there are a few things affecting this current. We're looking at an AC current from an outlet in the wall, not the DC current of the motor due to the setup constraints. I left this in anyway so the geeks out there can geek out with me on the data, as well as ensure that this is, in fact, the most in-depth sewing machine review on the internet. I thought it was pretty cool to see this machine go through 8 layers of regular fabric, but it didn't leave any stitches, so that was a fail. It was able to stitch 2 layers of denim, but not any more than that. Let's see if it'll go through some leather next. 1 layer. We made holes, but that's about all we did. We made 2 stitches together, and then we skipped all the rest. But we made some holes, so we got that going for us. Now time for the summary. First of all, this machine is very frustrating to operate. And it starts with loading that bobbin with thread. It is a very slow and tedious process, and you got to do it for your upper and lower bobbins. Not any fun at all. It came with a misaligned presser foot, so yours may also come with misaligned parts. Randomly skips a stitch, and don't forget about the lack of tension release, which makes it difficult when you're removing your work from the machine. And not only difficult, but it also makes it really frustrating because you keep pulling on that and it keeps trying to break the thread. I think we all knew what we were going to find when we tore apart this machine. A bunch of plastic gears and the cheapest metal you can find on the planet. But I didn't expect to find that plugging it in with batteries installed could be dangerous. The final verdict? If you're thinking that this would be a great machine to get your child to start sewing, think again. I wanted to throw this machine out the window just about every time I operated it. So if you want to teach your kid to be frustrated every time they want to sew, then maybe this is a machine for you, but I really don't see this being a good machine to teach a kid how to sew. Hey, thanks for watching. Hey, in order for me to continue to bring great videos to you, I need your support. So take a look down in the comments. There's a few things you can do to help out the channel. We have Amazon affiliate links, we have Patreon, we have other things that you can do to help our channel, and just take a look down in the comments below. Thanks a lot.